Welcome back, 7th graders. We are going to get into our first lesson out of the book today, which is 1, 2, variables, expressions, and properties. Again, here's a reminder of don't forget where you can look for other things to start understanding these concepts, get extra help, use your resources, and problem solve. So our target that we'll be working on is I can evaluate algebraic expressions using the order of operations. Yesterday we talked about order of operations and we reviewed our knowledge of PEMDAS, except then we were talking about numerical expressions. Notice the difference today is algebraic expressions. So we have to get through a little bit of vocabulary, which Ms. Simmers thoroughly enjoys, before we can kind of start operating with these things. So you can create this web we're going to create now, look at it again later when you're updating your vocabulary. Whatever suits you best is what we want. So right now, we're just kind of looking at the concept of algebra. What is algebra? Algebra is the branch of mathematics that's used is letters in place of numbers. It involves expressions that have variables. Those letters that are in place of numbers are called variables. Up here you'll see what a variable is, if I can find it and click on it here. There we go. A variable is just a letter in place of a number. So here I have examples of A, B, N, T, and X. Okay. Yesterday we did things with numerical expressions, so I thought that would be important to show you right now. Numerical expressions, we just had those operations. 3 plus 2. That's a numerical expression. It has numbers and an operation. 4 times 9, numbers and an operation. And 6 times 5 squared has 2 operations, the exponent and the multiplication, as well as numbers. And that makes it numerical. Notice how you don't see any letters. That's what makes it not algebraic. So then we were able to evaluate or to solve those by simply finding out what the expressions were equal to. So we did, 3 plus 2 is 5, and so on and so forth. So we can evaluate both things. What an algebraic expression looks like is very similar to what we have in a numerical, except for that there are variables standing in place of a number. So what number plus 2? A number A that has a different value. It can change. We could replace 1 with A, 3 with A, 17 with A. Same thing for 4n and 6x squared. Notice how when a number is next to a variable like that, that really means multiplication. And we'll talk about that a little bit more as well. Okay, so this is kind of a nice little web to get some vocabulary, organization, and understand what each thing is called, and so that you can use the language appropriately while you talk to your partner, while you talk to me, while you explain it to somebody else. It's always best to be using the right language and doing your best to understand what's going on. So, ways to show multiplication. Kind of a split screen. So if you could just look at the top half for now, kind of do that to not distract us. Ways to show multiplication in algebra. Previously, you guys have used an X for multiplication. We're not going to do that anymore because this is confusing. This could be 2 times X times N. That X for multiplication is commonly mistaken now for a variable when you're really meaning it as multiplication. So we do not want to use an X for multiplication anymore. What you can use are a couple different things. So if I said I wanted to see what 2 times the variable n was, it can be written as a couple different ways. 2 times n, when you just put a number next to a variable, so if I did 5 times t, the number next to the variable, that represents multiplication. Separating two values by parentheses also represents multiplication. If I want to do 5 times t, I could also separate that with a parentheses. And then again, we use this final dot, which you should be getting used to at this point, 2n. So 2 times n, still using a dot represents multiplication instead, because we're not going to mistake that dot for a variable like we would x for multiplication. That's a letter. And so when we're trying to use it as a symbol for multiplication, it can get a little bit confusing. Okay, so kind of steer clear from using the x as a multiplication symbol from now on. Another vocabulary word, it's pretty vocab heavy here in chapter 1. Expressions like 7 to the second power or 7 squared we've heard before, or x cubed or x to the third power are called powers. I've said that a couple times now. Powers represent repeated multiplication. Just like 2 times 2 times 2, we could show what that is. You guys know what 2 plus 2 plus 2 is, right? Isn't that just 2 times 3? So that just shows repeated multiplication, shows repeated addition. So we're going to have a way to show repeated multiplication as well. So 7 squared, or 7 times 7, is the same as this power, 7 to the second power. X cubed, or x times x times x, is the same as x to the third power. Notice how I'm using that word. So had I said this, well, this is 2 times 2 times 2, I really just take this base of 2. How many times does it show up? 3 times gives me my power. So maybe just try a couple. What would this look like? 5 to the fourth. What would that look like as multiplication? And similarly, what would this look like as a power? Take a second, you can try to work those out. And I'll show you as well. So this would just be that 5 is being multiplied by itself 4 times. 3 is being multiplied by itself 2 times. So 3 to the power of 2, 5 to the power of 4, and that's what the powers look like. This is a little bit, a lot of graphics, and it's in your book. I just wanted to pull it up so that you remember that you can look in your book and try to figure these out. Evaluating an algebraic expression goes through a couple things right there up on the top, and it shows you step by step of what to do. This is when you're given values for the variables. The variables, if it's not set equal to anything, just like an expression, it's a sentence, your variables can set equal to anything. You can choose, or sometimes the book chooses for you. And you just replace those variables with the number value that they represent. So here on the bottom, I'll try this first one with you and then give you some time to do the other two to check your understanding. Notice in your book you have a lot of these study tips too. Always kind of take a look at those and use those as helpful hints or reminders for certain things. So here we have 6 times c. I might rewrite this because it's kind of small. 6 times c plus 4 minus 3 times that's a value of d. Well, it says if c equals 3 or d equals 7. Knowing those two things, I'm going to replace c with a c value of 3 from this line here that tells us. Rewrite the rest and replace d with the value of 7 that it represents. Kind of again that same funnel concept from before. So now it's written in, I have a numerical expression again. With a numerical expression, I know that I use my order of operations or my PEMDAS to solve that. So here I can work my multiplication out left to right. I may do this at one time. 6 times 3 is 18 plus 4 minus 3 times 7 is 21. Now I have my addition and subtraction left to right. So 18 plus 4 is going to be a 22 minus 21. Bring that down for a value of 1. And notice, nice funnel, simplified it down just like that. Give the other two a try and then come back to that. pause me and then you can turn it back on. Doesn't matter. However it works for you. Or if you want to look at another one before you do it. So again, for B, I'm going to plug in the values that I'm given. So D would represent 7. C represents 3. And I plug those in where they belong. Then I use my PEMDAS to solve. So I see that I have parentheses, so I'm going to do that part first. 7 minus 3 is 4 squared plus 1. I also have an exponent here, so I'm going to do that part next before I do this multiplication. I have to go in order. So I have 4 times, since it's times here, I have to keep it multiplied down here. 4 squared is the same as 4 times 4. If I want to write it like that so I remember, I can do that too. This is kind of the same. These are the same, just rewritten differently. Continuing on, I'm going to do now what's in that parentheses still. 4 times 16 plus 1. So I know 4 times 10 is 40. I know 4 times 6 is 24. So I know this is going to have a value of 64 plus 1 for a value of 65. Again, worked it out. Nice. That way you don't have to draw those lines. I'm just showing that it makes a funnel like that if you're working it out correctly. Go ahead and give that C a try as well as we move on then into some other things. Another one, just for some of these, you have to remember that a fraction bar, you know, if you write a fraction, 1/2, this fraction bar is really 1 divided by 2. It stands for division as well. So that's going to be an operation in a couple of these that you'll see tomorrow and going forward. Notice how I'm going to evaluate, meaning simplify or solve this thing. Each expression, if P equals 5 and Q equals 12. So I plug those values in. So 3 times my value of P, which was 5. Notice how I use that multiplication symbol, minus 6, divided by 8 minus P, which is 5. What I do here is I work out the top and I work out the bottom and then I divide, because you can't do that without working out the top and the bottom. So I have 3 times 5 is 15, and then that's minus 6 on the top, and then 8 minus 5 is 3. So I did left to right on the top, and I did the bottom. I'm working them out kind of as separate expressions until I can work with both of them. And 15 minus 6 I know is 9, and 3 is alone on the bottom. So now I'm at that division spot, and I know 9 divided by 3 is 3. So you can do those same things to give the following two a try as well. They go very nicely. All right. Give those a chance. Go ahead and check. They're in your book as well, and you can give them a chance there using the example 3 on page 30 would be a good spot to try. We're going to talk about some properties as well. A property is a feature of an object or a rule that is always true. So if you're certain about something, it has a certain property or a feature. You know, you could say, I am a boy or I am a girl. It's a, you know, a fact, and so it's something that you consider true. So then that would be a property or a feature of you. The only one we're not going to talk about today is distributive. I took this right out of your book on page 31, if you want to turn and look at that spot. And I'm just going to give you some tips about what I like to think about them. The commutative property, I like to think of this one as commutative as commute or as in move. I'm going to drive a little car. Your parents say they have a long commute today. That means they're moving. Commute or move. They're moving from one place to another. So notice if we have them in algebra, which means we just have the variables involved, what happens with A plus B, it's the same as B plus A. So really you can just switch the order of your values when you add or multiply, and it's not going to change the answer. A more specific example with your numbers here is that I know 6 plus 1 is the same as 1 plus 6. They both end up equaling 7, so that's okay. 7 times 3 is 21. 3 times 7 is also 21. So I can move the order, and that's not going to make a difference. So I always think commutative, move, you can just flip-flop some things. Associative, what I like to think about is friends. Who do I associate with? Okay, who's in my group? Who am I friends with? Okay, and maybe it changes from time to time. We are in middle school after all. So if you look at the example here, you see today I consider it, okay, A for Alyssa is kind of hanging out. V is friends with, but today Bobby and Chris are they're best friends. And then the next day, Alyssa and Bobby want to be friends. And then Chris is still their friend, but he's on the outside of the group today. Same thing with multiplication. So you did those values with number. The whole point is that they remain equal no matter the grouping they're in for addition and multiplication. So if you looked on this side, this 3 plus 8 is 11 plus 2, which we know this is going to end up to be 13. Over here, 2 plus 3 is 5, plus 8 is still 13. So notice grouping 2 and 3 versus 3 and 8 did not change the value of that expression. Okay, so associative property is who is it grouped with? Who is it ordered with in that way for addition and multiplication? Identity property, this is identity addition of 0. So you can add 0 to any number and it'll still be that number. A plus 0 will still be A. 9 plus 0 will still be 9. And then the multiplication of 1, you can multiply any number by 1 and end up with that number. And you guys are pretty good about knowing those. But just think of it as the identity of that number does not change. You can add 0 as many times as you want, and that identity will stay the same the entire time. Okay, so think my identity will not change. So in your work today, you're going to be asked, tomorrow I guess, you're going to be asked to identify properties just by looking at them and then describing how you know. So for example, 4 here, which is on page 31, still in your book, you are going to name the property shown by the statement 2 times 5 times n is the same as 2 times 5 times n. So what I noticed is, well, I have all the same numbers in the same order, so the order didn't change, so it's not commutative. It's just like here, the order of the numbers and variables did not change, but what do we notice did change? We notice the grouping went from here, 5 and n, to now 2 and 5. So the grouping did change, so I know that it's the associative property of multiplication. I know it's multiplication because I'm dealing with a multiplication symbol. Then you can try the bottom two, G and H. We would write out a sentence occasionally. What I notice is that I have 42 x and y, 42 y and x. So I notice that these two, x and y, flipped positions. So since they moved, this one's going to be commutative. It's kind of a fun word. Commutative property. And what operation would it be? I'm wondering. Well, I see addition sign, so it's going to be of addition. Notice the second one is adding 0. So that's going to be the identity property of addition since it's adding 0. And sometimes you can write that identity and which symbol is it of addition. Very good. And then just the last thing for this is just a counterexample. Well, if you give a counterexample, it kind of sounds like you're arguing something. Someone tells me a fact that they think is true, and I have an example of something that doesn't work. So, and like we said, properties are something that's always true. So if you look at example 5, still on page 31 in your book, state where the following conjecture is true or false. So the following statement, is it true, is it not? If false, provide a counterexample. So it says division of whole numbers is commutative. We have to go back and think, what is commutative? Commutative, I know that I can move the positions of the numbers and it should stay equal. So then what I could do to prove this is not correct is do, well, 15 divided by 3 should be the same as 3 divided by 15. Well, 15 divided by 3 is 5. 3 divided by 15 is 1/5. Those are not equal. So that is a counterexample. And that division is not commutative. You cannot flip them back and forth. So go ahead and you can kind of read the bottom one and think about how you could represent it. These can be tricky because you have to kind of visualize what the numbers or what the sentences are saying to you. Okay, so kind of a lot of information in 1-2 here, but remember, go back and reread, rewatch. It should be fairly similar, our class time to our order of operations, just that now we have that variable involved. Kind of makes it a little bit more fun. It's kind of like a puzzle. So we will see you tomorrow. Make sure you have your notes ready to go.